Hey, welcome back to NTRAS. Just need to have a little conversation before we start on the 200-301. I just want to let you know that the way I teach is not direct information from the topics. I stray a lot. So just to be aware that a lot of my tangents are more for your, learning needs, and a lot of the things you need to look at when understanding, well, how do I pass my CCNA? But, well, what do I need to know as a network engineer? You're starting out in your career, you have to know that there's a plethora of information out there readily available for you. The CCNA and the books are very limited, so you're not going to get a lot out of them. Now, I could just regurgitate that information and allow you to pass the exam, but I feel that when people need to learn something to benefit themselves, we need to go beyond that. And if we learn a lot about what we're doing, it helps us understand better when we try to get a job in this type of stuff, okay? So, getting the CCNA is a good idea starting out. But when you go for that interview, if you can talk about a lot more than just what you read in the book, and can understand some of the topics we'll be talking about today, such as, network interface modules, service modules, PVDM, and how voice works in the Cisco realm. I mean, there's just so many things out there we need to know and be aware of, because IT and networking in general has really expanded a lot. So, with that, I hope you don't mind the tangents. If you do, let me know, and I can just kind of run through the information on the exam, but I don't like to do that, so hopefully you'll like it. Moving on, CCNA 200-301. We start here with our introduction. As I mentioned before, ntras.com and cisco.com is a really good place to look at all these exam topics and can learn a little bit more about each of them. As I mentioned in this particular course, we're going to be talking about how routers let us segregate and connect networks together, and how switches let us connect to many devices. So with this is what we're going to be talking about with Network Fundamentals 1.1a and 1.1b. So we're going to be talking about routers here. The whole point of a router is to allow information to flow across networks. Now in this case, routers and layer 3 switches can be used to provide those routing functions. See here I have listed out the EIGRP, OSPF, ISIS, RIP, and BGP routing protocols. A little later on down the road, we'll talk about routed protocols versus routing protocols. When you have protocols such as IPv4 and IPv6, or the Internet protocols, you're going to notice that, well, if I have an address and my neighbor has an address, well, how do I route from my address to his? And when we talk about layer 3 routing and the protocols, these allow us to intercommunicate, and that's what routers basically do. The problem is, you'll also see here that layer 3 switching is included on routers and firewalls and other various devices. So when talking about routers, we need to understand how they may be becoming more obsolete. Once again, my opinion portion of this is I believe that many chassis-based switches, larger switching, firewalls, and just new technology is coming out that's going to replace routers in a network. Now, not completely, as a lot of service providers, well, they use routers because that's what they need to do. They need to send information from one point to another very quickly and easily. So you might see us getting on some of these new ASR 1009 series routers because that's what they're meant to do. Basically a core/distribution of connectivity from one network or the internet to another. In the enterprise, it might be a different story, however. Routers give us the ability to run older hardware. They give us the ability to run server services, VDSL, VPN capabilities such as FlexVPN, etc. So In a smaller environment, such as your house or small office, you may not even need a router. I mean, in some instances, yes, I need a router because I'm running FlexVPN, and firewalls don't support that. You can't run FlexVPN and DMVPN on a switch. So you might need the router for that. To be fair, however, if you're looking at a certain solution with VPNs, well, you might be able to get away with a firewall in the VPNs you're attempting to use. Now, when it comes to VPNs, policy-based versus route-based is also another long topic that we can discuss. In the Cisco Firepower appliances, we have the ability to run point-to-point and point-to-multi-point VPNs. I have yet to really look into those yet, but I mean, that might be a reason to get rid of routers entirely. You can run a Firepower appliance in your data center or main office, and then send everyone out a Firepower 1010 appliance and use those as a replacement for all of your routers. I mean, there's a lot of questions, a lot of concerns, but you got to remember when we're talking about the roles and functions of routing and routers, we have a complex solution or a complex situation that we have to answer. Now, here's an excerpt from Cisco.com. Routers guide and direct network data using packets that contain various kinds of data, such as files, communications, and simple transmissions like web interactions. Now, to me, that sounds like a really old answer, but it's from a newer book. So you might have to have this definition from a certification standpoint, but from a real-world definition, well, other devices do the same thing, as I mentioned before, with Firepower appliances also guiding and directing network data, allowing us to send files and communications and transmissions between networks. Small networks, routers are pointless. That's my opinion. There really must be a reason to go the router route. Digital subscriber lines, that's an example of what you might need a router for. A little later on, we'll talk a bit about all of the interfaces and cards that we can install in routers that'll really give you a good understanding of, okay, I have this connection. What does that connection require? Okay, well, I have a T3 connection. Guess what? You need a router to do that. But you're like, well, I have an MPLS connection or a VPLS connection. Well, you don't need a router to accomplish that. A firewall, or heck, even a switch, could accomplish what you're trying to do. One of the other things you may have to be aware of is like IP phone services. If, like me, you have a VoIP phone that is managed via a SIP connection or the cloud, well, I don't need a serial link for this because my service provider has those T1s, has those T3s. They're the ones that get my internet, my phone connection from my phone to the PSTN. So they're the ones that have to run these DS1s and DS3s to provide that type of connectivity using, voice interface cards and whatnot. As a big example, I am running a Palo Alto PA220 and a Firepower 1010 as my internet edge. So basically, I don't need a router because my firewalls do everything I need them to do. They're the ones doing the routing on the internal LAN. They're the ones doing the routing and NATing to the internet. So in my case, I don't need a router because I don't need the functions a router provides. And in a moment, we'll talk a little bit more about, what they provide and what you need them for. But first, we need to talk about some of the various versions of routers. So, routers have the ability to run in a virtual version, which is installed on top of something like ESXi. We have the small desktop routers, which, keep in mind, we have desktop switches and firewalls as well. And then we have the smaller or fixed and modular routers. The 4K series is an example of a fixed small modular. And then we have the larger fully modular solutions such as the ASR 1004, 1006, and 1009 series. And, you know, as we sit here, we can take a look at those. But first, I want you to think about this. How do you connect to the internet? Odds are you have a Wi-Fi connection or are hardwired into some device that connects into your DSL or fiber or even a cable modem. Now that device that connects into the modem is your router, switch, and potentially wireless access point, and it may also do firewalling services as well. So if you have some time, try to figure out how to get to and manage that device, because it is your router. It's also your switch. So you can make a good understanding from that point of view how that device allows you to get to the internet and move between networks. Now, the likelihood of it having advanced router functions is very low. It's just kind of, here's a router, here's what it does, and now I'm on my way to learn more about Cisco. So from here, let's go over to Cisco.com, and we're going to be looking at various products and services for networking. You'll notice here right away that we have a lot of different options when it comes to Cisco, but since we're focused on routers, we're going to click on that. When talking about the Cisco routers, well, we have to think about what are the benefits and solutions to running routers. Cisco, of course, now has this thing called Network as a Service. If you're watching NTRAS, you know we are training as a service, so hopefully that's a good one for you. Features and benefits. Security across the WAN, on-demand network services, intent-based networking. Cisco's really getting into their SD-WAN and SD branch and a lot of other software-defined world. But what we want to look at here is these Cisco routers for all networks of all types and sizes. We can view all routers, try Enterprise Router Selector, and find our best for SD-WAN. So we're going to sit here really quick and look at small business. As I mentioned before, we have the 1000 series and 9000 series for the small office, home office, or remote office connectivity. These ISR 1000s are one of the best to get if you need connectivity into a home office using SD-WAN. As you're going to see here, we have 1, 2, 3, 4, 5, 6, 7, 8 different versions of the 1000 series. You'll see here that the 1000 series is running the iOS XE software. It allows us to do SD-WAN and has a bunch of different options when it comes to connectivity. 4 to 6 LAN ports, 4 LAN ports, 8 LAN ports. We have pluggable LTE in the 1101, dual pluggable LTE in the 1109, the 111X and the 1111X have PoE, so you can do power over Ethernet, where you can plug in something like a PoE phone or a, I don't know, PoE Cisco wireless access point. The 1120, looks like the 31 and the 1160 are where we're getting into portable options. So you have LTE, Wi-Fi, and DSL in the 1120. In the 31, we now have the ability to run Wi-Fi 6 directly from the router and has pluggable 5G options if you don't want to plug into an actual internet connection at a house or mobile. We can plug into 5G. And of course the 1160, it's a little older, replaced I believe by the 1131, that gives us an LTE option. So all of Cisco network devices have the ability to run different things. As a network engineer, designer, architect, what have you, it's probably going to be your job to go in here and look at a lot of the different devices to understand what they provide. Like anything else in this world, what do you need to do, what can you do, and what can you afford? So if we can afford these 1131s, well, you might as well go toward that. Gives us the ability to do Wi-Fi v6, 5G, SD-WAN, and LAN ports. Lets us do a lot of things, and then we can lock it down accordingly and allow or disallow certain features. Looking at the 900 series, well, the 900 series doesn't have the ability, at least from the screen, to run SD-WAN. However, if you don't want to run SD-WAN, but you're running something like the GetVPN, DMVPN, FlexVPN, or want to have an integrated firewall, well, the 900 series might be the way to go. The nice thing about these 900s, they have dual GigE, they also have 4 LTE, GigE WAN, you can put DSL, Category 4 LTE and DSL, or dual Gigabit Ethernet WAN. Interesting, they listed that twice. Oops. But like as an example, if your network is running a FlexVPN or DMVPN hub, well, you can use a 900 series model to connect right into that network cloud that connects you back to, say, your main office or data center. If you're running SD-WAN, you might want to pay a little bit more for iOS XE and SD-WAN on the 1000 series. The other things we need to be aware of course, we have our virtual line, industrial service provider WAN aggregation, which is the ASR line that we'll talk about a little bit. These 1000 series are big boys. They're huge, and they have a lot of different line cards to them and other various connectivity options. The ASR 1001 and 1002 are the smaller semi-module. They have interfaces that you can plug into them. They can do SD-WAN, SD access, they have software redundancy. The 1001 has 10 gig ports. Then on top of that, we have the ASR 1006 and 1009X that you can put your line cards into. Like a lot of these will be like 40 gig connectivity and like DS3 and T1 connectivity. A couple of last things here. Now the ASR 1006 and 1009 have hardware redundancy. If you can see from the pictures here, you're going to notice that the 1006 and 1009 have dual route processors. We have one here and one here on the 1009, the two on the bottom for the 1006. We have some ESPs, I believe those are embedded services processors, top and bottom on the 9, and right above the route processors on the 6. So the nice thing about the 1006 and 9 is that hardware redundant means you have the ability to switch back and forth between the different processors. So if you're running on route processor 0 or ESP 0, you can upgrade RP1 and ESP1 without affecting anything, and then fail over and upgrade the other two. The other nice thing is if you have a failure of, say, a route processor, you're fine. You're good to go. All you have to do is make sure it flips over, and then you can replace a single line card in the box. Now, when you look at the 1001 and 1002, they do have software redundancy, so there is a little bit of that within the software. However, if you ever have to do something like an upgrade, a base code upgrade or something like that, it could take down the entire box. So there's a good understanding of if you're going to have the 1001 and 1002, you potentially might want to have two of them. So like if you have BGP as an example connecting into your internet service provider, you can have them kind of do a load balance between the two where ASR1 and ASR2, they're both active-active, but they have connections to both ISPs. So there is a potential of doing that. And if you need to upgrade the iOS or the base code, you can take one down to do the upgrade, bring it back up, do the upgrade, and then you can make it load balance all over again. The thought process on the 6 and 9 is that you don't need to do that, but You know, it's been my experience that there are some times during an upgrade you're going to take down the entire box. So even though you have hardware redundancy, you might still have downtime, and it might be good to invest in 2 of those as well because of that reasoning. The ASR 6 and 9, you'll see that we have Ethernet port adapters and shared port adapters, and a few other things when it comes to the larger ASR line. To keep in mind, if you come down here to the bottom, there's a lot of really good resources if you want to do a little bit more reading on these. Like At a Glance is a really good one, and the data sheets are definitely some items you really want to look at. Over here we have the At a Glance. It's pretty short, but it gives a good amount of information about these systems. You get network speeds up to 200 gigabits per second on the route side, and of course 50 gigs on SD-WAN. All-in-one type stuff. It does talk about being application aware and being able to do these zone-based firewall services really fast on these boxes, so that's a good idea. The Cisco umbrella. But it also talks about the Cisco Catalyst 8000 Edge platform. I'm guessing you might have the ASR as kind of the internal aggregate and the 8500 as the edge aggregate. This is one of the things I need to look into as well, because if you look at the 8000 series, these are your SD-WAN, remote office, and aggregation at the cloud edge. So, I mean, you can run SD-WAN on the ASRs, or if you need kind of a multi-port solution for SD-WAN only, it could be a good idea to look at these 8Ks and maybe tie them into the ASRs. One of the reasons you might want to look into that is these SPA interface processors. They provide a lot of extra interfaces, such as copper, channelized T1s and T3s. You can do packet over SONET, SDH, ATM. There's even a WebEx node that you can install directly into an ASR. Looks like you install this into the SPA. You're going to see that there's a lot of options here. We have T3 SPAs, T1 SPAs, OC3. You can get 10 and 100 base fast Ethernet SPAs, which is interesting. And then of course you have circuit emulation, more OC3. You can go up to OC192 on these shared port adapters with the XFP optics. We also have our Ethernet line cards, so if you want to plug in, say, a 6-port 10 gig Ethernet line card, that takes up the entire line card section. So you'll see here, I believe these are the SPA adapters, but you can have full-length line cards like we see here, the actual fixed Ethernet line cards. And then of course we also have the modular interface processors, which allow us to do things up to, say, 100 gigabit per second gigabit Ethernet port adapters. And you could fit, it looks like, 2 of these into a single MIP. This one looks to have 1 of them here. 10 port 10 gig, 18 port 1 gig, 40 gig, and of course the QSFP 100 gig we just talked about. As you see, there's a lot of potential parts that you can install into these guys. You'll see here that we have the embedded service processors that you have to buy. They have different versions, such as the ESP 100 and 200. They have the new ESP 100 and 200X line, the route processors, and of course the chassis. Alright, this is where we talk about the ESPs. So the ESPs handle all network data plane traffic that's the processing in the ASRs, allow activation of enhanced network services, cryptography. If you're going to be doing IPsec connectivity, it's required to have an ESP for that. It does the firewall, NAT, QoS, NetFlow, and other such things. So you might want to not get the ESPs confused with the route processors. So the route processors will probably, handle the routing portion of the system, and the ESPs will handle some of this enhanced network services. So one of the things I was reading is that in the 1001 and 1002, you actually have the SPA and the route processors built into the box. That's why, of course, you don't have route processors or ESPs or SPAs or line cards, for that matter, because all of that is built into these. That's why they come out with the modular 6 and 9, because now you have options. You can get that ESP 200X or the 100X. The amount of throughput difference between the 1001 and 1002s is gigantic. I can't remember specifically. Here's one table. You're going to notice the 1001X is 2.5 to 20 gig, 5 to 36. The HX 44 to 100, 44 to 60, and 44 to 100. And the 1006, 9, and 13 on the back end go from 40 to 200 gigabits per second. So if you have a large enterprise internet edge, service provider, or data center edge that requires a lot of throughput and a lot of these really fast connections, SPAs, potentially DS3s and whatnot, you may need to go to the more higher end modular series. There's a lot of information in here. You have to worry about DNA licensing, various smart licensing options, various Cisco One software options. You'll see here that we have advanced services, advanced IP services, and IP base licenses. Cisco Thousand Eyes integrated into eligible ASR 1000 series. Interesting. Some of the use cases here are some good things to look into. High priority applications for high performance WAN edge, multi-service, scalable and secure headend, IPsec aggregation scale, 8,000 IPsec tunnels, 78 gigabits encryption up to 200. We have the embedded high-speed firewall, which is the zone-based firewall solution using Cisco's policy language, or MQC. Let's see, ESP dependent on the firewall performance. So the ESP 100, I believe, was limited to like 100 gigs. The ESP 200 was 200 gigs. Don't quote me on that, but that's kind of how it works. The version, maybe like the 200X, gives you 200 gigabits per second. Managed CPE for branch office. Of course, we mentioned high-performance SD-WAN aggregation. Of course, these are some of the things you also have to learn. When used as an SD-WAN head end, only modules with specified type and quantity are supported in the 1006. No support for route processor or embedded service processor intra-chassis redundancy. No ISSU or IOR, it looks like. So you might have to have two head-end devices for hardware redundancy. You can get up to 100 down to 10 gigabit ports for enhanced WAN edge, and some other various things such as next-gen voice. One of the nice things about these ASRs as well is they have the ability to run the Cisco Unified Border Element Enterprise Edition, or the Cisco Cube, which basically provides secure and authenticated SIP trunk connectivity for phone services out to a SIP PSTN service provider. Supports up to 16,000 simultaneous voice calls. So it might be a good idea if you're in a call center to look at ASRs. And then, of course, here's the chassis comparison and specifications. The ASR router has the route processor, ESP, and SIP integrated. So keep that in mind. Like I mentioned before, the 1001 and 1002 have those integrated into them. But you also have the ability to run some SPAs. For the modular line, the 4 to 9, let's see, you have to buy the SPAs you want. You have to get the specific ESPs, specific route processors, the RP1, RP2, etc. And of course, you can get the SIP cards. Memory solution, number of SIPs, number of shared port adapters, the different slots, Ethernet port adapter max, ESP slots. So it looks like in the 1004, where was that? One route processor slot, one ESP slot. So you don't actually have ESP and route processor redundancy in the 1004. However, in the 6 and up, you do. So as I mentioned before, it's a really good idea to look at a lot of the data sheets and product specifications to ensure what you're going to get, is going to do the job you need it to. So with that, we'll come back to our PowerPoint right here. I'll move on to the next one. Now, this is kind of a lot of the same stuff I talked about before, so we'll just cover it really quick. The ISR 1000 and 4000 and, of course, 900 series are meant for SOHO and remote office. You saw before that the 1000 series supported DMVPN, FlexVPN, GetVPN, and SD-WAN. The 900 series didn't support SD-WAN. The 4000 series, that supports DSPs. It also works as kind of a call element. So your 4000 series can do a lot of the call processing for your system. So if you have like a CUCM, the call manager, you can actually use a ASR 1000 whatever to connect into a SIP network. Or you can use the 4000 series to connect into the PSTN network. When we look at some of those T1, channelized T1s, channelized T3s, we can talk about some of the voice services. We can also run the Cisco Call Manager Express and use MGCP with the 4000 series, and it can be your call manager. So you don't actually need Cisco's Unified Call Manager. You can just straight up use a 4000. Until you get to a certain point where the CUCM really comes necessary. Alright, the ASRs, as I mentioned, it goes from Pizza Box to the 1013, which will be coming end of life for the next couple years. The 1009X is pretty much the next version. We talked about that. One of the things that we did have to worry about was the ISR 4Ks. They only support 4 SFPs or 4 copper interfaces, and some support digital signal processors. We'll move to the next one, but what I want to do is come back in here to the Cisco products and look at networking again on the routers for the 4000 series. So the 4000 series products, you'll see here that currently it looks like we have 4 available. On the 4461, we have the 10 gigabit SFP pluses, 10 gig performance, all the way down to the 4221 that has Gig E and SFP integrated WAN ports, and it's only 1.2 gigabits per second performance with 75 meg encrypted throughput. The 4461 has up to 7 gigabits encrypted, so depending on what you're going to use these for, say you have a DMVPN or FlexVPN headend and you don't want to go the ASR route, a 4461 would probably be your best bet. Let's see if we have a data sheet down here. Okay, let's see. Alright, so here's a couple pictures. You're going to notice that the routers have built-in ports and they have expansion ports. That's not a good picture. Hopefully they have a better one. It does not look like it. Alright, performance factors. Performance licenses. So that's another thing to keep in mind, that you have to get a performance license to get the best performance on demand. And there's also booster performance licenses. Interesting. Alright, some specifications, that's a good idea. The 4200, the 4221, the 4321, they have 2 onboard Gig E, 2 NIM slots, 1 ISC slot, 4 gigs of RAM, flash. The 4331 now has 3 onboard Gig E, 2 NIM slots, 1 ISC slot. This one has 1 service module. The 4351 has 2 service modules. The 4431 has 4 NICs, 3 NIM slots, and 1 ISC slot. The 4451, which used to be the top model on the 4Ks, is 4 onboard Gig E NIC, 3 NIM slots, 1 ISC, and 2 service modules. And now the ISR 4461 has 4 onboard Gig E, 3 NIM, 1 ISC, and 3 service modules. Okay. Here you also have to worry about the data plane and the control plane. But let's move up a little bit and see if we can find some other information. You need certain licensing: DNA Essentials, DNA Advantage, and DNA Premier. We'll talk about that a little later. Product specifications, where you can look at the aggregate throughput by default and aggregate on the performance license. So here the 4461 says 3 gigabits per second max, 4451 is 2 gig max. Aggregate SEFT only with the boost license. All the information we just kind of talked about. Let's see. More DNA Center information. Cisco Integrated Services card slots on the motherboard. So if it has an ISC, this is where you would support the high density packet voice digital signal processor module, or the PVDM4. This provides the media services for voice. So if you're going to use one of the ISRs as a voice system, you need to make sure that you can run some of these PVDMs to do the voice digital signal processors. We have the NIM slots, which we'll talk about in a minute. And of course the services module. The SMX is the enhanced services module. So let's go back here really quick and look at the interfaces and modules. You also see that we have the SMX layer 2 switching module and the interfaces and modules. So you can add switches to this router. Now, one of the nice things about this is say you need a router at a small office, but you don't want to go the 1000 route. You actually want to go the 4000 route because you might have I don't know, local voice services. So you might want to buy one of these ISR 4Ks that connects into a voice network for voice offloading locally. And you don't want to buy like a 9300 series switch. You can plug all of your equipment or endpoints into this switch module, and it'll have basically a back-end data plane connection between the router and the switch. So you can have two separate devices physically in a single device. These are really good, once again, for kind of remote offices, small remote offices, without extra switching, of course. When we come to the interfaces and modules, this is where we talk about some of the options, such as server blades. So you can actually install a server into a router. Coming down here, you're going to notice we have the ability to run certain UCSE blades within certain router versions. So as an example, the UCSE double wide 8-core CPU, 2x 8 gig SD card, 8 gigabit, I guess, I don't know why they did that, RDIMM, and 1 to 3 hard drives. So it is possible to run multiple routers at multiple remote offices and just have these UCSE servers in the routers. We talked about the Ethernet switches. These are all of the Ethernet switches we have. Let's see, these are the service modules. So as we saw before on the layer 2 service module, the switching module, this is a switch. That's all it does. And it is basically a secondary device in your router. You actually have to like SSH into the switch to manage it. These NIM modules right here, these are actually switch ports that are built into the router itself. So you would configure these switch ports from the router. Now, traditionally, NIM ports were very limited in what they could actually do. So if you wanted a lot of the iOS XE coolness of an actual switch module, these won't do that. All they'll be able to do is a certain amount of Ethernet switch NIM support. So keep that in mind as well. We do have a couple of extra SMX ES3s here. These might be older considering, but these are layer 2 switch modules. Yeah, so these are layer 2 and layer 3 service modules. So if you want to have a layer 3 switch, these are your options. We have extra Ethernet routed ports that we can install as NIMs. A 1-port NIM, dual mode SFP or RJ45. But if you want to get into the actual higher port count or faster ports, you look at the service module Ethernet ports. So you have 6-port GigE. This one is a 4-port gigabit Ethernet or 10 gig. So you can put a 10 gigabit Ethernet SFP module in your Cisco 4K router. We have wireless WAN, so you can go up to 5G. Of course, these only list 4G, so that's kind of a question to be had there. It looks like these are all NIM modules, so you'll have to have a NIM port if you're going to do wireless WAN. For the T1E1 and G703 trunk voice and WAN interface cards, we only have NIM options. You have up to an 8-port trunk voice or clear channel data T1 module, so you can have, in this case, up to 8 T1 connections. The PVDM, so the Packet Voice Digital Signal Processor, if you're going to be running voice. You'll see here in certain versions we have these PVDM 4s up to 256 channel that go in every device except the 4221. Once again, these are DSP modules. I'm guessing these go on board. However, you do have the ability to get up to 256 channel voice DSP module in the NIM factor, and up to 3080 high density voice DSP in the service module connector. Keep in mind the 2048 and the 3080 is only available in the 4461. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like you can run the 2048 and the 3080 in the 4451 and 4461. If you have a 4351, you can run the 1024 or 768. So once again, you have to choose your router, service module, PVDM, or NIM accordingly. Voice interface cards. These actually connect you into the FXO or FXS. So basically a way to get into a direct phone connection, or the, I believe it's FXS is the ISP, the PSTN. So if you want to connect to FXS, that goes up to the 4-port in the FXO or FXS. Let's see, NIMS, and then of course you have the service modules. These go from the 8-port FXS, 12-port FXO, single wide. And they also have the service module X72, which is a 72-port double wide service module. So we looked before when we had 1, 2, or 3 service modules. Well, according to this, if you want 72 ports in a single card, it'll use 2 of those service modules, so keep that in mind. We have broadband capabilities running VDSL, ADSL. These are all NIM connections. Serial WAN. So if you have a requirement for serial WAN, I haven't seen these in years, but if you have a service provider or old system, you might still have to use these. Async WAN. If you're running an ISDN phone connection using BRI. And then, of course, we have the channelized T1 and ISDN PRI, which allows us to do the flex trunk voice and channelized data module. So that's cool. We have NIMS and service modules for storage. And then, of course, here's a listing of all of your transceiver modules. Dense wave division multiplexing. I believe that's carrier wave division multiplexing. SFPs for gigabit Ethernet. 1000 base SX for multi-mode. Multi-mode and 10 gig. 10 gig LR. These might be single mode connectors. So yeah, there's a lot of stuff to worry about when dealing with Cisco routers. There's what do you need to do and what do you need to buy to do it. It's kind of how it is, right? But yeah, so there's a lot to talk about on there, and that gets us back into our PowerPoint here. Once again, like I mentioned, Ethernet routed ports, wireless WAN, the T1, E1, PVDM for digital signal processors, the voice interface cards that get us into the PSTNs, broadband and ISDN connectivity, channelized T1s. These are all NIM options. Service modules, the E-Series server blades, dedicated Ethernet switches, routed ports. Once again, you can have PVDM in a service module, as well as the voice interface cards. And I believe that's where we looked at earlier, the Cisco URL at the bottom. So getting back on to the roles and functions. Personally, as a network engineer of 16 years, I don't like the book's definition of a router. Routers work with switches in a complementary manner to provide WAN access. You know, a lot of the things we just looked at with the T1s, the T3s, the OC192s, DSL connections, async and serial lines, wireless WAN. I mean, those are all things that you need to get onto the WAN with those types of connectivity. Moving forward, however, the whole point is, well, buy what you need for the job. Will a firewall work, or do you need a router to do it? As I mentioned before, Linksys, D-Link, etc., those are routers. You're probably running a router at home right now. If you're going to be running CUCM, you will require Cisco routers to act as PSTN or POTS gateways. We mentioned earlier with the PVDM, the T1s, the T3s, all of the voice cards. Cisco Unified Border Element, or Cube, for the service-provided SIP trunks. So keep that in mind. We have some of these things as well. Now, one of the things I also wanted to mention is SD-WAN. Now, the current support for SD-WAN is on the ISR devices, the 1000 ISRs, and the 1000 ASRs, as well as the Catalyst 8000 series. So this is again one of those questions with SD-WAN. So if you have a Catalyst 8000 series that's doing your edge services or your edge aggregation, you might still have to have some type of ISR 4K or ASR 1000 line if you have, say, T1s, T3s, or OC connections in your network, because you might have to connect that 8500 back into the router to get those specific WAN connections. But kind of moving forward, a lot of systems like VMware and their Velo Cloud SaaS solution, Palo Alto with their CloudGenix solution, and Cisco with their Viptela solution, well, that really depends on what type of connectivity you have. What we say in the SaaS, or Secure Access Services Edge, SD everything, well, on the Palo Alto solution and the VMware solution, if I'm not mistaken, you only have Ethernet connectivity with those options. So if you're running T1s, T3s, or OC connections, you will still need that router. But moving forward with VPLS, MPLS, cellular, wireless WAN, all these things that really don't require anything but Ethernet connectivity, well, that's why I say something about routers are not going to be necessary anymore. 8000 series for SD-WAN, firewalls for other edge services, or even, you know, the multi-point VPNs that the Firepower appliance has on it. I think this might have been about as long as I want to do on the router portion. So I was going to do routers and switch, but I think we're probably pushing about 50 minutes on routers now. So I'm going to end this one here, and then in the next one we're going to get into the roles and responsibilities, whatnot, of switching. That's probably not going to be an as long video, so we'll go through kind of the same stuff we did with routers. We'll take a look at some of the Cisco 93 and 9500 series, but we'll also dive a little bit into the data center switching as well, so we can kind of understand the iOS XE, some of the NextOS, and maybe some of the iOS XR that's in the ASR 9000 series. I think those are coming to their end, but we'll talk about that in the next series. So again, I know it was long and a lot of information, but I hope you stick with us, and see you in the Switch one. So I'll see you next time.